UK unveils new Tempest fighter jet to replace Typhoon. The Defense Secretary has unveiled plans for a new RAF fighter jet, the Tempest, which will eventually replace the Eurofighter Typhoon.
After years of planning and global collaboration, Britain is set to unveil its most ambitious warplane, the Tempest. This sleek sixth-generation jet combines stealthy design, strong engines, and superior artificial intelligence to push the limits of modern air combat. The Tempest, developed with partners from Italy, Sweden, and Japan, significantly improves weapon delivery, pilot support, and unmanned drone coordination. But what secrets lay behind its beautiful surface, and how might this affect the future of aerial warfare? As global countries compete to develop sixth-generation fighters, the United Kingdom is stepping up. While the United States leads with planes such as the F-22 and F-35, China's J-20 and Russia's Su-57 have joined the fray. Britain refuses to fall behind. The Tempest project is intended to challenge or outperform them, with cutting-edge engines, AI co-pilots, and classified weapons technology. It represents the UK's return to the forefront of fighter innovation. The name Tempest carries historical significance. During World War II, the Hawker Tempest replaced the Typhoon and helped defeat Nazi air forces. Now, as the RAF prepares to retire its current Eurofighter Typhoon, the Tempest moniker reappears, this time representing the future of aviation. The program launched shortly after Brexit, as the UK attempted to boost its defense sector, create high-tech jobs, and defend its economy. With France becoming the EU's sole nuclear and aerospace leader, the UK developed its own fighter program to maintain competitiveness and independence. In the 2015 Strategic Defense Review, the United Kingdom committed to developing a next-generation aircraft under the Future Combat Air System, FCAS. In 2017, the UK and Japan formed a collaborative fighter development team. Defense Secretary Gavin Williamson outlined a new aviation strategy in early 2018, followed by the unveiling of a full-scale Tempest model at the Farnborough Air Show in July. The Tempest has stealthy delta wings and two outward-angled tail fins. BAE Systems is in charge of the overall design. MBDA handles the weaponry. Leonardo UK is in charge of sensors and electronics. And Rolls-Royce is producing the next-generation engine. The UK has pledged more than $2.6 billion to take the Tempest from idea to flight by 2025. At first sight, it may resemble other current jets, but its true advantage is hidden beneath. The airplane has a modular plug-and-play system. Sensors, fuel, and weaponry can be configured according to mission requirements using bays and mounts. This adaptability allows for updates without requiring a whole redesign, ensuring that the jet is future-proof. Even its construction is high-tech. BAE intends to 3D print up to 30% of its construction. This process, which uses metal powders, reduces waste, saves time, and enables for complex interior designs that reduce weight while increasing strength. The United Kingdom is developing more than simply a jet, thanks to multinational collaboration, vast finance, and modern manufacturing techniques. It's creating a platform that will be ready for the future. Tempest is intended to evolve, adapt, and dominate for decades, maintaining the Royal Air Force at the forefront of air combat. The Tempest fighter has a gently elevated rear fuselage to allow smooth S-shaped air ducts concealed behind twin-engine inlets. These ducts, neatly integrated into the body, diminish radar and heat-seeking visibility by concealing bumps and hot spots. The jet's slim form and tucked-away heat sources, like those of previous stealth aircraft, help it avoid opposing sensors. All fuel and armaments are kept within, not on exterior pylons. This keeps the jet's silhouette tidy and decreases radar signal while increasing empty weight. Engineers strive to strike a balance between the Eurofighter Typhoon and the F-22 Raptor. While internal storage increases mass, the Tempest compensates with powerful engines to maintain speed and agility. The jet will require a significant quantity of electricity to power powerful sensors, weapon systems, and cooling technology that conceals its heat signature. Rolls-Royce is developing engines that can produce high thrust while operating at extreme temperatures. This increases fuel economy, allowing the jet to fly longer or carry more without burning too quickly. Efficient power and heat management systems will direct electricity where it is required while keeping systems cool. Rolls-Royce is aiming for 1 megawatt of onboard power, which is 10 times greater than the present Typhoon engines. That is sufficient to sustain strong radar, EW equipment, and cooling systems. To accomplish this, they are embedding the starting generator directly into the engine core, bypassing the traditional gearbox layout. The E2SG embedded electrical starter generator program started in 2014. Originally, a starting generator was mounted inside a jet engine. By 2017, the team had implemented energy storage and smart controls to better manage power flow. Upcoming enhancements will strengthen power loops and thermal controls to better match real-world flight requirements. Stealth fighters frequently appear in infrared. Therefore, converting the engine into a power plant and cooling system is critical. Smart controls will allocate energy to thrust, electronics, and heat dissipation. This integration improves the Tempest's ability to hide from heat-seeking systems compared to prior jets by combining a bulging fuselage, hidden ducts, internal bays, and smart engines. The Tempest becomes stealthy, agile, and difficult to detect. It pushes the bounds of power, stealth, and speed beyond what contemporary fighters can provide. Rolls-Royce's planned future jets would require more electric power than conventional engines could offer. Their E2SG program replaces a hefty, complex gearbox with an internal starting generator integrated directly into the engine shaft. This unit starts the engine and provides power to the aircraft while in flight, saving space and lowering failure points. In Phase 1, they demonstrated that it could start an engine without a gearbox. In 2017, Phase 2 included energy storage and proprietary software for managing power flow. The system may thus balance electricity across multiple systems, even during peak demand periods such as powering sensors or cooling stealth coatings. Power might come from the generator, the battery, or both, allowing everything to run smoothly and consistently. The Tempest design was further advanced in the third phase, which was scheduled to launch in 2020. Rolls-Royce is creating two distinct electric loops inside the engine, similar to backup generators, to increase output. They're also improving thermal control by incorporating innovative heat exchangers and smart materials that collect or release heat depending on flight conditions. All of this is linked to a central power management system, which continuously regulates engine speed, power output, and heat flow. This allows the engine to power high-energy lasers and several sensors simultaneously without overheating or increasing weight. Meanwhile, Leonardo UK is developing the Tempest's cutting-edge electronics in 4 crucial areas. First, they are developing radar and electronic warfare systems with digital beam shaping, which will allow the radar to follow many targets or zoom in on a single one. They are also quickly developing a wideband RAF sensor that can switch modes to identify threats like as enemy jets or ground radars. Second, they're combining radar, infrared cameras, electronic signals, and drone data into one system. Third, pilots will use AR and VR overlays in their helmets or displays to see flight paths, targets, and warnings right in front of them. Finally, an AI co-pilot will assist in making quick judgments, reacting faster than humans, and taking over immediately if the pilot blacks out under severe G-forces. The Tempest, which combines Rolls-Royce power technology and Leonardo smart avionics, claims to be a next-generation fighter. Its engines will power laser sensors and cooling systems, all with a lighter design. AI in the cockpit assists pilots in maintaining an advantage in combat. This combination of power technology and AI seeks to keep the UK Air Force on the cutting edge for decades. To rule future skies, the Tempest will require powerful weapons and adaptive systems. One proposal is to equip it with 6 to 8 missiles kept within, while keeping its design covert. However, official figures have yet to be established. For reference, today's Eurofighter Typhoon typically carries 4 to 6 long-range missiles, 2 to 4 short-range missiles, a 27mm Mauser cannon, and 3 fuel tanks. Future Tempests may employ collaborative UK-Japan armaments, such as the JAM missile, which combines Japan's sophisticated seeker technology with MBDA's Meteor ramjet motor to provide a quick, long-range, precise air-to-air missile. The Tempest might also carry next-generation cruise missiles capable of hitting ships or land targets, replacing the present Storm Shadow/Scout missiles. These sophisticated weapons fly low to avoid radar and attack at great range, making them perfect for covert, high-impact operations. Drones are perhaps the most futuristic and devoted wingmen, flying in swarms with Tempest fighters. These autonomous aircraft scout, jam radar, fire missiles, and serve as decoys, completing perilous tasks while safeguarding pilots. As jets get more expensive and complex, commanders benefit from these cheaper, expendable drones, which provide more options and lower risk. To speed up Tempest development and divide the expense, the UK enlisted global partners. At the 2020 Farnborough Virtual Air Show, then Defense Secretary Ben Wallace stated that 7 additional corporations had joined the core team, establishing the Tempest Consortium. These included GUK, a joint venture between GE and the UK, GKN, Collins Aerospace, Martin Baker, Kinetic Weapons Tech, Spirit Aerosystems Airframes, and Thales UK, a sensor and electronics company. They're collaborating on more than 60 new technologies, ranging from engine parts and stealthy airframes to AI systems and next-generation cockpit displays. Each company focuses on a particular area, reducing costs and speeding up deliveries. All of the missiles, drones, improved cruise weaponry, and global teamwork are aimed at assuring that Tempest and its wingmen continue to lead air combat into the future. The UK is combining proven British knowledge with new global input to create a smart, stealthy, and powerful fighter. In December 2020, the United Kingdom reached a deal with Italy and Sweden outlining each country's technology, financial, and R&D duties. Japan soon stepped in, promising to co-develop a testbed and a prototype radar system known as Jaguar for Tempest. The engine test rig will simulate harsh flight circumstances, while Jaguar will evaluate sophisticated radar modes that can quickly switch between search, tracking, and jamming, which are critical for 6th generation fighters. Tempest development isn't inexpensive. The UK intends to pay more than $8.3 billion, which is still significantly less than the US Air Force's $29.5 billion for the B-21 Raider stealth bomber. Despite the hefty cost, quickness is crucial. In July 2022, officials reported that a flying prototype would be ready by 2027. BAE Systems engineers in Preston are currently manufacturing and testing essential components. Prior to complete production, early flight testing will collect critical data on aerodynamics, stealth engines, and systems. The RAF plans to put Tempest into service by 2035. This allows for more time to train pilots, modernize infrastructure, and create tactics for a fighter equipped with stealth, advanced sensors, artificial intelligence, and unmanned aerial vehicles. By collaborating with Italy, Sweden, and Japan, the UK has access to Italian materials, Swedish radar technology, and Japanese engine expertise while keeping costs low. With this collaboration, Britain intends to not only keep up, but also lead in shaping the future of air combat.